Here's an example of using that formula to find the surface area of a shape that we're familiar with, in this case a cone. If you have the segment joining the origin to the point HR, so you go over H and up R, then that's going to create this segment. So we already have the parameterization x equals ht, y equals rt. You can see that works perfectly because the slope of this would be, let's see, dy dt is r and dx dt is h, so the slope is r over h, right? And it goes to the origin. So we've already got the parameterization. If you rotate this or revolve this around the x-axis, then it's going to create a cone. And so if we could find the surface area of this, we could find the surface area of the lateral sides of a cone by using our formula. Remember, the formula is that the surface area equals the integral from the starting time to the ending time of 2 pi. In this case, the radius here is y, so that's going to be rt. So 2 pi y times the square root of dx dt is h, so h squared, plus dy dt is r squared dt. So let's see. This has dx dt has no t dependence and dy dt has no t dependence, so this has no t dependence, it's just a constant. So everything that's constant can be pulled out. We have 2 pi r times the square root of h squared plus r squared times the integral from 0 to 1 of t dt. And the antiderivative of t is 1/2 t squared, so we have 2 pi r times the square root of h squared plus r squared, and we have 1/2 t squared evaluated between 0 and 1. So we have 2 pi r times the square root of h squared plus r squared. If we plug in 1, we get 1/2. If we plug in 0, we get 0. 1/2 minus 0 would be 1/2. This 1/2 wipes out that 2. So we have pi r h squared plus r squared. H squared plus r squared. If you look on a cone, it has height h and radius r. This square root of h squared plus r squared is actually what's sometimes called the slant height of the cone. So sometimes you see s or l because it's the slant length, which would be h squared plus r squared. So you would probably find this formula in a geometry textbook, that this area of the sides of a cone is pi r l. So